We have a session here. We're going to give the next 30 minutes. We're going to focus on ArcGIS Runtime and the augmented reality and virtual reality experience that we've built thus far, leveraging ArcGIS Runtime, the technology that we deliver today as part of our native application solution. So I want to be relatively quick, kind of go through a couple of slides, just talk a bit about what the solution is today that we have, and then Adrian's going to finish the latter half of this presentation with some more details on the beta offering that we have and take a look at some code and some of the applications that you can build. So the primary focus here is to talk a bit about the capabilities that we have in the Runtime SDK product today. So we've delivered a number of major updates to ArcGIS Runtime over the last year and a half. We've also included 3D support fully across desktop and mobile platforms, and really building on top of that existing 3D capability within Runtime. We want to, which is already integrated within the ArcGIS platform and supported fully on multiple platforms and devices. We want to be able to take that to the next step, right? Take it to another level so that you can take advantage of the capabilities that are built into Runtime, which means you can take advantage of device resources, sensors, capabilities that the device has access to, so that you can build out a better, sort of a more immersive 3D experience through virtual or through augmented reality experiences. So the first part here was really just taking that 3D experience that we have in Runtime and modifying that slightly to support a virtual reality experience, which means just changing a perspective, changing a view, and providing really a stereoscopic view and an ability to maneuver or work with our API to maneuver within a 3D scene. So that provides the ability to support our virtual reality experience, where basically you're simulating a location within a virtual world. So completely replacing your physical reality with a virtual reality, and really basically immersing yourself into the 3D scene. The other option is augmented reality, right? And so with augmented reality, we had to make a couple of changes here within the API to just simple changes, where basically we hide the background grid in a 3D scene. We make the background transparent, and we enable the scene itself to be displayed on top of something like a camera feed, right? And that camera feed might be coming from a device that you're holding in your hand. Could be coming from another feed if you're looking at something maybe in the back office or on a desktop. But inevitably, the field of view that you're working with respect to a 3D scene in the context of Runtime in your application includes basically a camera feed as your backdrop, and it's basically supplementing that virtual content on top of this camera feed to supplement your physical world. A couple things to think about with augmented reality. There's really two different contexts. One is a small scale experience where you're working with models, almost like an AR sticker, or maybe almost like a holographic experience, where you're working with small scale representations of virtual content, kind of like what we saw at the Dev Summit Planner this morning, right? So a small scale representation of downtown San Diego, and we can interact with that if we have sensors, and we integrate with those sensors in a way that allow us to interact with the virtual content appropriately. Another concept is full scale, right? So being able to work at room scale or full scale, where basically you're supplementing the existing full scale representation of physical reality, and you're augmenting that or supplementing that with additional virtual content. So for example, if I use my device at this stage to view this room, I might be able to pan over to the wall and see pipes or electrical wires or something behind the wall. I might be able to see additional furniture added, or other objects within my physical reality, and actually honoring my full physical scale. So a couple different ways to support augmented reality. With ArcGIS Runtime today, we have a private beta program that started in November 2017, so it's been just over 3 months now. We are targeting high-end mobile devices, so we are looking at mobile devices that can support 3D experiences most effectively. And that's to provide basically a good frame rate, high resolution, working with the best chipsets in the market, so that you can provide the best experience possible, notable for being able to maneuver your device and actually have it track along with the virtual content that you're actually viewing within your scene. It's pretty important as well. Another part of this is making sure that you're working with devices that support a number of the AR kits, like AR Kit for iOS or AR Core for Android, so that you can work with or provide the best experience possible within your surroundings. Right now, the the beta program is limited to the runtime SDKs for .NET, iOS, and Android. When we just released an update to this about a week and a half ago. It's built on 100.2. And so 100.2 introduced a lot of new and additional functionality, whether it's data source access or analysis, like what we saw this morning in the plenary. And so you can build those capabilities or those features and functionality into your virtual augmented reality experience. The beta program itself has a number of samples and toolkits, a variety of source code and some documentation to help you get started. There's also, if you're looking to join the beta program, there's an email alias, which is listed here, ArcGIS Runtime, ARVRBeta@esri.com. Send an email and request access, and we'll try and get you guys in as soon as possible. As soon as possible, if you haven't already. Oh, is that right? With that in mind, I'll go ahead and hand it off to Adrian, and he'll take us on a little tour through the beta program and show us some code.
Thank you, Rex. So I'm sorry if you're coming to see something super sexy looking AR application. I'm really gonna try to get you from scratch to actually build your first AR/VR application. So it's a lot of web pages, code and everything, but hopefully after that you have a good understanding on what you can build and you can go and start building your AR/VR application. So I'm on 3, here you are. So the first thing is going to happen when you log into the private, when you join the AR/VR private beta, is that you're going to have access to this website. This website is the way where we can communicate, where we can drop new beta DLLs and everything. So you have a page with actually a YouTube video that goes to exactly what I'm going to discuss today. So step by step on how you can start from scratch and finish with an AR and VR application. Using either your phone as a sensor or AR kit to get more fancy locations. Then the resources is what you're going to download to be able to get the bits you're interested in. So as Rex mentioned, we have so far 3 SDK. We have iOS, Android, and .NET. So .NET, that also includes Xamarin, which means that you can just write your .NET code and target iOS and Android through Xamarin. That's all supported part of the beta. So everything that is working in update 2 of the ArcGIS Runtime SDK will work in that beta, and then you will be able to render it in a virtual environment or an augmented reality environment. The only exception that we have right now is when you drape graphic, that's actually pretty GPU expensive operation to do. It's not something that a lot of people do when you actually drape the image on the ground. We don't support that in VR, just for performance reasons. It is still a beta, obviously, because there's a lot of work and improvement that we're working on, and VR performances are definitely an area of focus right now, trying to get the frame rate higher. So what happens when you actually download the bits on your computer? So you end up with either an Android developer, then you will have first, all the libs that you actually need for you to be able to start programming, small readme tags, and you have a full documentation that is pretty common for Android, iOS, and .NET. Talking a little bit about what is augmented reality. So first, the system requirements, how to install it. So obviously that's specific for iOS, Android, or .NET. And then a little bit about what is augmented reality, what is virtual reality, and how you can actually start building your first application using the bits that you just downloaded. So Android, .NET, and iOS have the same things. I'm just going to drill into, I have the Xamarin code here open. So for those that are not familiar with Xamarin, you can actually create one project, Xamarin Form in that case, and that's where you put most of your logic, and then you might have some specific Android and iOS UIs that you want to tweak, so you still have an Android and an iOS project, but try to put all your code there, and then you actually can target both at the same time. So that works also part of the beta. So I'm going to go quickly about what is specific about building a VR application and an AR application for the ArcGIS Runtime SDKs. So as I showed this morning, I just have a normal scene with an operational layer, which is right now, I think it's San Diego, and some elevation. And all I do is exactly what I showed this morning. I just change my rendering to be a stereo rendering. And the side-by-side barrel distortion is the one that you use to be able to have those two displays that look like kind of a globe on both sides to counteract the lens distortion. And that line is the only VR-specific line you will need to add to your existing 3D runtime application to make it a VR-looking app. In AR, the only line that you will need, so is this time I'm having a scene and I'm just adding the same just the building of San Diego. The only line you will have to add in AR is a property called isARMod_enabled. And what that will do, it will get rid of everything that you don't need to show, which is the space effect with the stars that you see in a default 3D application. Get rid of the atmosphere. And in the 3D application, if you don't have any data, you will see the grid, the gray grid. So having that option will just get rid of all that. So your app will be completely transparent. So maybe I should start just for VR to try to show you directly what it looks like. But let's keep with VR then. And so I just changed my stereo rendering to be the side-by-side. And then the same thing I mentioned this morning, the only thing I need from there is to be able to have the orientation of my phone to actually control the scene view camera, because I want them to be in sync. If I look north, I want to be able to look north. And if I move like this, I want the scene view camera to do exactly this. So I want my phone sensor to control my scene view camera. To do this, we introduced last year some camera controllers. So we have one that was automatically following a graphic. And now for the VR and AR experience, we have a first-person camera controller. And so that will basically take control of the camera, and then we'll be able to feed a lot of different positions. And to feed those positions, we use what we call the motion data source. So motion data source are going to connect to your sensors. So on the phone, it could be the compass, the magnetometers, and all those sensors. And that will control the positioning of your phone. We have an ARKit motion data source also for the iOS SDK and also for the .NET SDK targeting iOS. We don't have an AR Core motion data source because we released our beta about a day before Google finally released their AR Core as a final version. So we will obviously have that available in our next beta. And so the difference is that the phone motion data source will connect to, as I say, the compass and the accelerometer and things like that. When the AR kit, we just connect to the AR kit. So basically, iOS is providing us with a matrix of transformation from an initial position to wherever I am. It's really good at tracking small movements. And so all we need to do is target the AR kit motion data source. And that takes care of connecting to it and doing all the work for you. You don't have to do anything. Same with the motion data source. It would just do everything for you. Then you just, say that your first-person camera controller is going to use your phone motion data source that you just specify there. Specify that your first-person camera controller is going to be controlling your scene view. And then all you have to do is start using your motion data source. So I'm going to show you what it looks like when you just, run this application. Once again, it's an application that is part of the SDK. So if you download the bits, you're going to have that application. You just press run, and then you're going to have that experience. So you saw the grid quickly. The internet is pretty slow, but that was good because you saw the grid. That's mean we're in VR, so we still display the gray grid that we saw earlier. And in AR mode, that will be completely hidden. The internet is really, really slow. So you're going to have buildings coming in eventually, but you get the idea. The only stuff I did there is two things I talked about on the main stage, is change the stereo rendering and then connect to the phone sensor using the first-person camera controller. Just by adding this to any existing 3D application, you can actually move your application to be now in VR. So let's move back to AR. And as I mentioned here in AR, so in VR, all I had to do is change the stereo rendering. In AR, all I have to do is say, oh, I want to be in AR mode, which make all those things transparent. Notice that in the first case, I actually added a base map in the imagery, which is what you're looking at right here, if internet was a little bit faster. In AR, obviously, I don't want to show the tiles. I just want to show the buildings. So they will pop up like in front of me. The other thing I will need in AR is the background needs to be coming from your camera feed. So in the case of ARKit, it's a really simple definition to have. You just enable the ARKit and it just works. If you use the phone camera, then it's a little bit of code. And it's, of course, specific to iOS or specific to Android. In our samples, we already have that code written for you, so you can copy that and put that in your project. But that basically connects to your hardware camera, make sure that you have access to it, and then make sure that the layout is correct, that it takes the full view of your background, and then put that as a background. Make sure that if you rotate also, it takes the full space available. And so it's a lot of code just to get your camera feed as a background, but it's all written for you, so you can just grab that and put that in your application. We have the same code written for iOS, and we have the equivalent also on a separate project on ARKit. So now all I have here is basically my scene, the San Diego building, and I'm saying that everything should be transparent. And the problem with the San Diego building is that it's a lot of more data than just the tiles that we showed earlier. So I'm guessing that will take even more time to come.
So because we're showing on an Android and we're using an emulator, actually having to pipe that through the Visor app takes a little bit longer too. So the responsiveness on the phone is better than what you see in the emulator, just so you're aware.
I'm going to try to see if I can
increase the bandwidth or
increase the
bitrate.
Better responsiveness. But yeah, maybe you can try to connect to a different network, because that doesn't seem to work. Yeah, can you try to connect to a different network? Yep. Yeah, so you have some Wi-Fi issue, doesn't download any data. So what I showed you is out of the box. I didn't write any code yet. I was just looking at the sample app and something that you can download and just press run and then deploy to your device and just start playing with it and understanding what are the bits that are added. So one of the things I wanted to mention is that I mentioned that we only have a phone motion data source and an ARKit motion data source. You might want to connect to devices like the HTC Vive and other things like that. Motion data source is an external class, which means that if you can actually inherit from the motion data source. That will allow you to actually connect anything, any devices you want, any sensor you want to connect to that will direct your camera, and you will be able to control that first-person camera controller. So we went even a little step further, and we actually we have a small toolkit for the .NET API, and we're actually showing you the code of the phone motion data source and the code of the ARKit motion data source. So, the phone motion data source, if you're familiar on connecting to your sensor, that's the type of code you will write to connect to your sensor. You choose the accuracy that you want, and then you have a lot of different conversion to do if your phone is in portrait mode or in landscape mode. And so we have all that source code written here. And you can choose to updating your location, which means it will actually also use a GPS. to know where you are, or you can choose to only update the angles. You know, if you want to be like right now, because we actually have some data that came through. So right now I'm showing San Diego buildings on top of the camera, which is obviously not where I would want to be. But that's to give you an idea of just a few lines of code I wrote earlier. That's what you get. And obviously here, all I did is call the start angles, which means it's just reacting to my angle change. If I look right, it goes right. If I look left, it goes left. Obviously, it doesn't use my location. Otherwise, I will be back in Palm Springs, and I will not be looking at the San Diego building. So we can start updating the location, or we can start updating just the angles, which is another function. Here it is. Or we have a start all, which just means, you know, I want to start where I am, and I want to update the angles right away. So we have the source code for the phone motion data source, the source code for the ARKit motion data source. So that's definitely more modern and way easier to understand. If you're familiar with any of that iOS code, you will find, you know, exactly what tracking through an ARKit is about in those lines of code. So you can inherit, because that's actually a public class, you can just inherit from device motion data source and then connect to any sensor you want, even if it's not provided out of the box. And because we only have a few minutes left, and I don't want to leave you by just showing you code when we talk about AR and VR, it's kind of sad. What I'm going to show you is just the developer test projects that we worked on, you know, part of developing the SDK. And most of those projects is something that you can write. Once you know the bits, you can write that in less than 10 minutes. This one is a little bit more, so that's an indoor routing application. Obviously, you need to know your location, which is a big issue indoor, so you have different solutions for that. And here you have another approach where I know where I am. I'm going to tell ARKit, oh, there's an apple here. And because I know where I am, he knows what I'm looking at, I can actually add that feature. I have the GPS location of that feature, and I can add that to my feature online. Here's just a simple application where I'm just looking at the fly path, going over the office, or the pipes underneath the ground. Once again, it's just a thin layer. It's really just a thin layer, and everything else is transparent. Here, it's just a proposed building on top of our current parking lot, which I don't think got approved. Or you can actually have, as Rex mentioned, the small scale model where you can actually put the model on the table and be able to interact with it exactly like if it were in the model. And once again, just the VR application, just by those few lines of code, you can just put that inside a cardboard and run it inside. Yeah.
Great. Thanks, Adrian. Good stuff. So a couple things, just a reminder on the beta. If you guys would like access, send an email to the address that I mentioned before. A couple things we're looking for. We're looking for a, let me get that address back up there again. You got it. You're good? Is it right? You got it? Oh, you got it. Okay, cool. A couple things we're looking for in the beta is we're looking for some feedback on this capability, right? So this is something that we built on top of the existing runtime SDK at this stage, and we built it on top of the 3D capabilities that are in runtime. So it's not a new product, it's not a separate toolkit, it's actually just a private beta of features that we look to add to the runtime product, right? And so what we are looking for in the beta program is feedback on the API, because the API makes sense, right? Is it something that's useful? We're also looking for any success stories. These could be simple success stories, applications of this technology in a specific industry or to solve a specific problem. Also, we are looking, because it is a developer product, the phone motion data source and the other different devices that you can target, such as an Oculus Rift or an HTC Vive or a variety of different headset types, they all have different sensor configurations and capabilities. And so being able to enhance our library of phone motion data sources to integrate with those products would be helpful. So if you're a developer and you're looking for a challenge, there's something to dive into and maybe contribute back to the effort that we have within Runtime to be able to support some of these different device capabilities. There's a lot of different devices, headsets in the market today. Some are more popular than others. And so because they do have different sensor configurations, it would be helpful to kind of get some feedback on the phone motion data source that you might build to make it work with those headsets. So a couple different things we're looking for. API feedback, success stories, maybe some contribution there on the phone motion data source capabilities if you want to take up the challenge. So with that, I think we've got about 3 minutes left, so we might have time for a couple of questions, maybe 1 or 2 questions. Any questions? Yes? Okay, so question is future plans on being able to more accurately place basically virtual content, GIS data indoors. So a lot of that has to do with device capabilities, right? And frameworks that enable you to accurately locate the device and then also the positioning of the virtual content, right? And so what we're trying to do is we're trying to build on top of those location-aware systems, actually, whether it's GNSS or it's working with beacons or Wi-Fi, or you're working with other mechanisms such as sensors that are on the phone, to be able to provide a relative location, like we're talking about with ARKit or ARCore, which provides you with a relative sort of positioning within a specific area. And so a lot of those can work together. And so we're in the process of basically building on basically a toolkit or a set of tools on top of capabilities that you find within the industry, right, to provide a better sort of location awareness. Actually, not just where you are on your perspective, but where other GIS content happens to be. Right. Any other questions? Yep. Right, so right now, just to reiterate, this private beta is built on top of ArcGIS Runtime SDK 100.2. Right, 100.2 was released in December. It's a commercial release. What we've done is we've taken 100.2 and we've enhanced it with some additional capabilities to light up the VR AR experience in our 3D support, actually. So if we get feedback to indicate that this is useful and workable, we'll introduce this into a commercial release of Runtime. There we go, guys.
I just wanted to complete the location issue because that's a huge problem in AR. And one of the solutions that we have is right now we have a project that just scans a GPS location. So now we know exactly where that tag is, and ARCore is giving us how far we are from that tag, which heading we are, and everything. So now we know exactly where the phone is, and then we can use ARKit's relative positioning to actually position in global positioning our phone. So that's one of the solutions you can have to try to fix the problem of location, which is a huge issue in AR.
Another note, ideally, because the runtimes themselves are designed to be synchronous across different SDK products, is that although this is in .NET, Android, and iOS now, the idea is that if this is available as part of a commercial release, that's available in all SDKs. Right? So it's not just tied to those just happen to be the most popular right now at this stage. But it would be in all 6, conceivably. And with that, I think our time is up, actually. So thanks for joining us. If you have any questions, feel free to come up to the front. We'll try and get some answers for it. Thank you, guys.